Shuaiqi, if you want to share your screen, we'll be going over the Earth System Model Aerosol-Cloud Diagnostics package.
Yep. Can you see my screen and hear me?
Yep, we can see your screen and hear you.
Okay. Now it's the slideshow, right?
Sorry, what was that?
So you see my slides, right?
Yes.
Is the
yes.
slides okay?
Yep.
Okay. Yeah. Thank you. Thank you, Adam. I'm Shuaiqi Tang from Pacific Northwest National Laboratory, and today I will introduce you and also make a tutorial of the Earth System Model Aerosol-Cloud Diagnostics package, or we call it ESMAC Diags. So this package is developed under EGOS project to focusing on the evaluation of aerosol and clouds in the Earth System Model. Brief introduction of what is it. So it's a diagnostics tool to evaluate the Earth system models. So currently we are focusing on the ECSM model. And since actually we have a lot of different diagnostic tools to evaluate Earth system models, but most of them are using like satellite data or like global reanalysis data to make a global evaluation. And our focus here is to evaluate on Aerosol-Cloud and Aerosol-Cloud interactions, more focusing on the process level evaluation. And so this is mainly using the in situ and the remote sensing measurements from arm and also some other field campaign measurements. It's not a global evaluation, but only focusing on a few locations. This diagnostic package is, of course, it's an open source package. So, and the goal is to facilitate the routine evaluation of aerosol clouds and aerosol cloud interactions, and provide some insights to guide the future model development. In this tutorial, I will go through some basics of the diagnostic package, from how to download and install it, how to prepare the observational data, as well as the ECSM output. And I will have you do some like hands-on exercise to make how to make a diagnostics plots. Also give you some references and links. So on the right, I'm showing some examples from the ESMAC Diags. This is the mean aerosol size distribution. For instance, the ECSM version 1 is like produce more acre mode aerosols and less accumulation mode aerosols. And also we compare the vertical profiles with aircraft measurements, getting the performance of CCM number concentration in each different levels. And it shows that the model produce CCM number concentration pretty well. We also have some like time series plots to see that the model cannot produce the high day-to-day variability of the fine particles that's relevant to the new particle formation events. Yeah, some examples from the diagnostics package. To download code and install it, I will go to the ARM notebook to go through this, and you can follow me. So this is the Jupyter Lab, ARM Jupyter Lab. Maybe Adam or Max, you can copy the link to the chat so people can follow that. And I'm going to Jupyter Hub. So here is my main directory, and I can see all the tutorial information on the left. And then, I will need to clone the code. May I also pass it to the chat? Yeah. Yeah, you can do it under your directory, and it takes about 1 minute to download all the code. Yeah, it's done now. Let me see. Okay. Yeah, it's already installed. That's pretty good.
Yeah, we already installed it for you. It's on the hub already.
Okay. Okay. Yeah. So this part is for the running on the NERSC supercomputer that because ECSM is many simulations are run on NERSC, so we also do this on the NERSC. So this is only for the Conda virtual environment. So there are something that we need to activate the Conda environment. But here, I think in the ARM notebook, we already pre-installed that, so we can skip this part. And we also don't need to check use any branch. Okay. So yes, if it's already pre-installed, I will skip this part.
Yeah, you should be able to just go within the ESMAC Diags.
Yeah. Let me make a quicker hack. It's already installed. So if you don't see any error information when do an import ESMAC Diags, then it works. Okay, now I will move to prepare the observational data. So all the observational data can be directly downloaded from ARM or other agencies like the NCAR field campaigns. So all this information of the data we used is put in the README PDF file. I have this in the ESMAC GitHub. If you click the README PDF and very important. Yeah, we can see all the data used for each field campaigns, the instrument, the data stream name, and all the DOIs. So you can get that. And all those input data, we did some pre-processing, quality controls, and also change the time resolution to facilitate the evaluation of ECSM output. Because currently ECSM is running at like a 1 degree resolution with 1 hour output. But for observations, especially for the Aerosol-Cloud measurements, many of the field campaign measurements are in very high resolution in like a second. So we do the different types of averaging, some to see median value, some to see mean value, or some measurements, if they are like in a coarse resolution, I interpolate them depending on the data, the variable itself, and to standardize the time resolution to evaluate the model output. So all these prepared observational data currently are put on the NERSC, and we are now working with ARM to trying to like release it as a data bundle or maybe archive it so that the people can get them publicly. And all this pre-processing code is also archived in the GitHub. If we, if we want to like do some additional quality controls or add additional data, we can like revise the code and use the script to do the preparation by ourselves. or otherwise we can just get the prepared data. Let me see is there questions or something in the chat? Okay.
We're just specifying where it can be found when people load it onto the Jupyter Hub.
Okay, yeah, I will go on. So this figure shows the field components currently included in the package. So we are currently focusing on the 4 regions, the ARM SDP side, ARM ENA side, for the true field components high scale and ACNA. And the Northeast Pacific, we have the ARM Magic field component as well as the NCAR CSAT field component. The red line is the ship field component Magic, and the black line is the aircraft component. Also the Southern Ocean field component Marcos and Socrates. And here showing the information of all the 6 field components. Also, we want to mention that the ongoing development of the version 2 of ESMAC Diags will also include long-term diagnostics at SDP site and the ENA site, so we can get a better statistic evaluation to the ECSM. Yeah, now I'm moving to the preparation of the ECSM output. So I don't know how many of you are working on ECSM or have any projects working on that, but yeah, if you are not working on that, you can still use the diagnostic package to evaluate some other models, the regional models, or do some more observation to observation comparison between different instruments or measurements, and it's also doable. But here, yeah, if you are not familiar with how to run ECSM, I would direct you to the ECSM webpage or GitHub to get the guidance of run the simulations. And specifically for the ESMAC Diags, we typically require high frequency ECSM output, also with nudging simulations to the field components so that the model and observation can be directly compared with their similar meteorology fields. To ensure that they are high frequency output, we need to change the name list. For example, here the 2 parameters indicate that we have the output is in the 1 hour resolution, 24 variables each day, 24 times each day. And all the variable names output in hourly is defined in this fin CL2. Also, it gives the location, region, domain of the hourly output so that we don't need to output hourly output from the globe, just need to specify the several regions covering the field component. If the model is successfully run, then we can see the hourly output in this daily files in the ECSM directory. Then we use this ECSM output to do some preparation to extract the variables we need to evaluate the model and calculate some other additional variables. I have provided some preparation scripts in the code base so that people can prepare the model output. It generates 3 types of datasets. One is the from bottom to top. One is the surface level variables, but it also includes the TOA variables and the vertical integrated variables like liquid water path. Also have the vertical profiles for the standard UVTQ, relative humidity, and the cloud fractions. We also extracted the ECSM output along the flight tracks for each flight field components. Here we output the nearest degrees and time along the aircraft track. Although aircraft is flying very fast and the environment is very high frequency, although we extract it to the nearest grid and time, the ECSM model is in much coarser resolution, so the time series is very smooth. We do this because we are targeting on the version 4 of ECSM simulations, which is going to like a very high resolution, like 3 kilometers. So that comparison will be more fair. But here we have this capability here, and we can also do some statistic evaluations. Yep, and then I will briefly introduce how to make the diagnostics plots and do some hands-on tests. So again, the top part is for the NERSC environment, if you are using Conda environment. So on NERSC, the default, you can see a base before my account. And on here, so we don't have this modular installed. Every time when we log on it, we need to activate the environment. And when we see this, then the package is now installed. Now it works well. And in the ARM notebook, we don't need that because it's already installed. So for now, let's go to the tutorial directory. So I believe it's ARM notebook. Open Science Workshop Tutorial, ESMAC Diags, ESMAC Diags test case. And let's go to scripts. I think okay. Yeah, they have rewrite them into Python notebook format. The diagnostic package currently is writing in Python format to just run it in command line on NERSC. So it's easy to do it in the notebook also.
Yeah, just for the purpose of the class, I moved all of the scripts into Python notebooks for people to see how they work. So if you were to navigate in that project navigation screen to your left to the notebooks.
Yeah, I know.
Yep, so you can run all of these, and it's just your exact same content of your scripts moved into a notebook format.
Yeah. So just show of the Python format, and this is the notebook format. Yeah.
And just a heads up, in case anybody does prefer the command line, ran out of time to adjust the file paths on the Python scripts themselves for running in this Jupyter Notebook environment. But the file paths have all been adjusted in the Python notebooks themselves. So the scripts will run inside the notebooks. you'll run into file path errors if you use the .py extension, just because they haven't been updated yet. But if you download those Python files and are running things on your own system, just remember to check all the file paths and make sure they're going to the right place.
Yeah. Okay. Yeah, I will use the Python code to talk since I'm more familiar with this structure. Yeah, so the script is generally includes several parts. Yeah, this is firstly it's importing everything and setting the different data paths, reading data, and if we want to do some specific data treatment, we can add something here. So because the data we output for high scale is combining the two IOPs, and now I only select the first IOP to make plots. And then this is the plotting part. If we run it in the notebook, just click the run, or maybe do a shift enter or something, then we can see it generate bar plots of different aerosol compositions from observations, version 1 and version 2 of ECSM. Yeah, I can also do it in NERSC. On command line, you can see we have all this example code here. Let's do a Python example plot bar composition. Then it will also generate the plot, and I believe it will pop out the figure. Wait a second. Yeah. Okay, just the screen does not show everything on the Nagion. Yeah. And the figure is also output in the figures directory, high scale, surface. Avita, do the output. Okay, you comment out the save figure, so it did not run. You don't save the figure. Let me see if I can. Run it in command line on notebook. Because here in notebook it does not write. So out. Does it work here? No. Okay. Yeah. Here is seconds ago. The output figure is saving here. And then we can look at that. So let's go back to the script. And we have some other different examples. Okay, notebook, sorry. Is it running? Oh.
You go to the tab towards run, you can hit run all cells.
Yeah, I'm just not sure if it's running or not. Yeah, on NERSC, I can simply do this and
So if you're not sure what's going on, you can.
Yeah. Now it's going here. Yeah, under script pops up here. Yeah. Let me see. I was trying to like copy everything in the Python format to the Python notebook. For example, here I'm creating a new Python notebook. Let me do it again. Python notebook and pause everything here. And click run. Yeah, here is run, showing the run status and the plot. Yeah, in my end, I work for this. Yeah. So this is the end. I'm showing some useful links and reference here. The paper for describing the ESMAC Diags version 1 is recently accepted in GMD, and we are working on the version 2 now. And the code you see here is actually the version 2. And now we have a few minutes that if you have any questions on doing the example runs.
All right. Are there any questions? There is one here. Do these data include an estimate of uncertainty for each observational variable?
Yeah, this is a good question. We have different, yeah, we do want to so that they have different uncertainties, and sometimes actually in many times it does not include all those the uncertainties are not included in the data. So for example, for the vertical profiles in the top right plot, we use the percentiles, the 5%, 25%, 75%, and 95% percentiles to indicate the variations as well as the data uncertainties. Also in this plot, we also include the, this is also percentiles. Use this to estimate the potential data uncertainties. Yeah, in this plot, I haven't added those variations. Yeah, in this plot, I have not, but it's doable to add in the variations. Yeah, if we have the uncertainty estimate that's other than the variations, we can also add them the shadings or the uncertainty bars on the plot. Yeah, it uses the matplotlib to make plots, so it should be pretty easy to add those.
Ian, does that answer your question? I guess while you're responding there, are there any other questions?
I'm going to the links and the references.
Yep. Would feel free to put those links into the chat here as well, for easy access there to the group.